All right, let's talk about building a fortress. We're diving into the huge public world of Amazon Web Services, and we've got one big mission: to figure out how you carve out your own secure, private network right in the middle of it all. So, let's get into it.
You can think of the AWS cloud as this massive, sprawling city. It's open 24/7, traffic is everywhere, it's totally public. So how on earth do you build your own private estate inside that city? One with its own gates, its own security, its own private roads? That's the puzzle we're going to solve today.
And the answer from AWS is pretty elegant: the Virtual Private Cloud, or VPC for short. Now, this isn't a physical thing. It's a logical boundary that you draw in the sand. And this gated community analogy, it is the perfect way to understand how all the pieces fit together. So let's use it to build our fortress from the ground up.
First things first, IPs and subnets. We're laying our digital foundation. I mean, every community needs a plot of land and a basic street layout, right? Well, in our digital world, that means claiming our address space and then carving out different neighborhoods. This is square one.
It all starts with something called a CIDR block. Now I know, that string of numbers might look a little technical, but the idea behind it is super simple. It's just you telling AWS, hey, I'm claiming this specific chunk of private IP addresses for my community. This one line of text defines the size and the absolute boundaries of your entire digital estate.
And just how much land are we talking about? Well, a single /16 block, like we just saw, gives you, get this, over 65,000 unique IP addresses. That is a massive amount of digital real estate. It gives you more than enough room for all your apps, servers, and databases to grow for years without ever worrying about running out of space.
Of course, you wouldn't just build one giant warehouse on that whole plot of land. That'd be crazy. Instead, you'd create different neighborhoods for different purposes. And that's exactly what subnets are. We take that big CIDR block and we chop it up into smaller, more manageable neighborhoods, each one designed for a specific job.
And this is where we start defining those neighborhoods. A public subnet is like the commercial district of your community. The welcome center, the storefronts, it's designed to talk directly to the outside world. This is where you put your web servers. A private subnet, on the other hand, well, that's the secure residential area. It's totally shielded from the public internet. This is where you keep the crown jewels, like your databases and application servers.
All right, next up, route tables. We're directing our network traffic. So we've got our neighborhoods mapped out, but how does anyone actually get around? We need digital roads, and more importantly, street signs to tell all the traffic where it's allowed to go. In our VPC, that's the job of route tables.
So here's how it works. Every single subnet we create gets its own route table. You can think of it as its own dedicated GPS or traffic controller. It's really just a simple set of rules that looks at every little packet of data and tells it exactly where to go next.
And this right here, this slide shows you the secret sauce that makes a public subnet public. It all comes down to this one rule, that 0.0.0.0/0 is basically a universal address for anywhere and everywhere on the internet. So this rule is saying, hey, any traffic that isn't going to another house in our community should be sent straight to this one specific gate, the Internet Gateway.
So let's talk about those gates. Any good gated community is only as secure as its entry and exit points. In a VPC, these critical access points are managed by a few different types of gateways, and each one has a very specific, very important job.
Okay, this comparison is absolutely crucial. The Internet Gateway, or IGW, is your main entrance. It's a big, two-way gate that connects your public areas to the whole world. But what about your private neighborhoods? Your databases still need to get out to download security updates, right? That's where the NAT Gateway comes in. Think of it as a special service gate that only opens from the inside. Your database can push the door open to go out and get a patch, but nobody from the outside can use that door to get in. It is essential one-way security.
And now for the security layers, your digital firewalls. We've got our layout, our roads, and our gates. Now for what is arguably the most important part of all, the security guards. AWS gives us two distinct layers of firewall protection, and you really need to understand both.
And it's really important to think of these as layers of defense. It's not an either-or situation. The best practice is to use them both, working together to create this really strong multi-layered security posture for our entire community. So let's see how they're different. This is honestly the best way to understand the difference. A security group is the guard at the front door of each individual house, your server, your database. And it's stateful, which is a huge deal.
It means it's smart. If you let a friend in, it automatically remembers them and lets their response back out without you having to make a second rule. A network ACL, on the other hand, is the guard at the entrance to the entire neighborhood, the subnet. It's stateless, which means it has no memory. It's way stricter. It checks your ID every single time you come in and every time you leave. You have to write explicit rules for both directions. But that strictness gives you a superpower, the ability to create specific deny rules, which is something a security group just can't do.
Okay, time for the grand tour. We've seen all the individual pieces. Now, let's put it all together and see how they work in perfect harmony by following a single user's request from the internet all the way to a secure database and back.
So let's follow the data. A user clicks a button. That request first hits our main gate, the Internet Gateway. Instantly, the public subnet's route table, its GPS, directs that traffic over to our web server. Then, the web server's personal bodyguarded security group inspects the request and says, "Yep, you're good," and lets it in. The server then needs data, so it turns around and communicates with our database, which is tucked away safely in the private subnet. And finally, if that database ever needs to download a security patch, it uses that special one-way NAT gateway to get out without ever being exposed to inbound traffic. See? Every single component we talked about playing its part perfectly.
And that brings us to what is, honestly, the most crucial point. You just can't throw things into the cloud and hope it all works out. You have to plan. Thinking through your IP ranges, your subnets, and your security rules from day one is the absolute key. This kind of foresight prevents massive headaches later on. Trust me, trying to fix overlapping IP address spaces when you need two VPCs to talk to each other, it is a total nightmare.
So, let's just quickly recap the blueprint for our fortress. Number 1, your VPC is your private gated community in the AWS cloud. Number 2, you divide it into public neighborhoods for things that face the world and private ones for things that don't. 3, you put a smart, stateful security group guard at every single house and a stricter, stateless NACL guard at the entrance to every neighborhood. And finally, you manage all your gates with a two-way internet gateway for public traffic and a secure one-way NAT gateway for private resources.
And that leaves us with one final thought to chew on. Building one of these secure fortresses is a fantastic start. But in the real world, a big company might have dozens of these VPCs. So how do you connect all of those different gated communities together securely and efficiently? Well, that's a whole other can of worms and a challenge for another day.